My name is Lexi Blake, and my topic is brain chemistry. What is brain chemistry? Brain chemistry is better known as neurochemistry. According to NCBI, neurochemistry is the study of chemicals like neurotransmitters. These chemicals make up the physiology of the brain's nervous system. When was brain chemistry first discovered? According to NCBI, examination can be dated back clear to the 1700s. It was first noticed when Luigi was looking at frog legs, hanging from copper hooks of an iron balcony, and they twitched. According to NCBI, these twitches were powered by neurotransmitters. Neurotransmitters are the body's chemical messengers. It is exactly what is sending a signal to my mouth to move. Brain chemistry discoveries. According to the birth of neurochemistry, the first examination of brain tissue was done by Johann Hensing in his book called Cerebri Examen Chemicum. According to the birth of neurochemistry, this was the first book that faced the chemical makeup of the brain. According to the article, How Brain Chemicals Influence Mood and Health, there are 4 important brain chemicals: serotonin, dopamine, glutamate, and norepinephrine. According to the article, How Brain Chemicals Influence Mood and Health, serotonin plays a big role in appetite, arousal, mood, and sleep. It functions as a neurotransmitter to send signals to nerve cells. Dopamine. Dopamine is also a neurotransmitter. According to How Brain Chemicals Influence Mood and Health, dopamine controls behavior, emotion, and cognition. Many illegal drugs target dopamine's receptors. Glutamate. According to How Brain Chemicals Influence Mood and Health, glutamate is a neurotransmitter essential for early development, learning, and memory. Norepinephrine. According to How Brain Chemicals Influence the Mood and Health, norepinephrine is a neurotransmitter connected to the body's stress response, which creates the fight or flight response when paired with adrenaline. Key developments. According to NCBI, 4 key developments are fluorescent microscopy, imaging neuromodulation, FRET-based protein sensors, and self-powered electrochemical systems. Fluorescent microscopy. According to NCBI, this is an optical microscope used to study organic and inorganic substances. This allows for brain imaging and was first tested in mice. It is different than the normal microscope, though, because it uses fluorescence instead of scattering, reflection, attenuation, or absorption, but it can be paired with these things. Imaging neuromodulation. According to NCBI, imaging neuromodulation is a safe and non-invasive way to stimulate the brain by sending ultrasounds into the nervous system. It can be used to diagnose where pain is coming from because it targets specific functions. If you look at the picture above, it is showing what is lighting up when certain ultrasounds are sent out. So when these signals are sent out, whatever part of the brain is activated is what is lighting up. FRET-based protein sensors. According to NCBI, these are used in brain imaging. They are 2 fluorescent probes bind together at a protein. Self-powered electrochemical systems. According to Royal Society of Chemistry, self-powered electrochemical systems is a person's own body system. This could really lead to advancements because it would allow you to figure out what you can do to stop and start certain systems. Who uses brain chemistry? Doctors and neurochemists. Neurochemists. According to NCBI, neurochemists look at why people do what they do based on chemicals in their brain. They try to find answers for diseases. This is done by brain images and scans. So they would be looking at what chemicals are making a person act what way. Doctors. According to NCBI, doctors use neurochemistry to conduct scans of the brain. They also use their findings to treat people with mental illnesses. Neurologists use brain chemistry to determine how to remove tumors and to safely do brain surgeries. So the neurochemist would really look at why things are happening and what needs to change. So like what chemical needs changed, and then the doctor would go ahead and prescribe the medicine to change that chemical imbalance. Positive impacts. It allows us to create advancements in medicine. It provides answers for why people deal with certain illnesses. Negative impact. It could lead to too many advancements, causing a low death rate, which in return would cause overpopulation. Also, going the other way, if we didn't have neurochemistry at all, we wouldn't have certain cures for diseases or treatments for diseases. And we really need these treatments because the brain is so sensitive that if we don't take care of it and something were to happen, it's irreversible most of the time. Conclusion. We need neurochemistry because the brain is so fragile, and without it, we are nothing. It literally tells us to do everything. So we really need to protect our brain. And when we do see some, like a chemical imbalance, we need to treat it. And there are my references.